And I've now got the pleasure of inviting to the stage the person in the audience with the most interesting headgear here. Is Andrew Vladimirov, who's an information security expert and DIY brain hacker. I suspect the headwear may well be something to do with that.
Oh, I've got more.
Excellent.
In the bag of tricks. Should I
watch the
drag it?
Wow.
Andrew. Sorry, can I grab my seat? I need to no, it's my. I'm sitting there.
Oh, sorry, that's all right. No worries.
Just
I thought
so I have to jump up and down.
Yeah. Oh, on the end, yeah.
Andrew. Feel free to carry on your conversations through direct mental stimulation, which probably coming up next.
Right. Not everything works as intended. Do I have a mic or...
Don't you have a microphone? Aren't you wearing a microphone? Sounds like you're wearing one.
Well, fine.
Where is it? The microphone's hidden.
Yeah, never mind. So, a few intro slides here.
Can't you? Did somebody give you the microphone?
Oh, this one did.
No?
Have this one. Tell them. Number 4. Yes, number 4.
One. Okay. That's a bit better. Sure. So, in the beginning, I will provide a brief introduction of where we are at now on the topic of accessible, meaning accessible to everyone who really wants it, neurostimulation. And then for the rest of the talk, we're going to explore where it might go in a very recent future. But in the beginning, the usual slide of why. You know, I'm more interested, as Kevin Mitnick supposedly said, you know, the question is never why, the question is always how. So I'm more interested in hows myself, but I guess there would be few people who are new to the topic and who would be interested just to know why on earth we are doing this. So, first of all, it's obviously a cognition or performance enhancement methodology or set of methodologies, which could be task-specific, which could be generic, for instance, long-term memory in general, or it could be combined. Then, again, when it comes to the argument of why do we need to enhance a healthy human rather than just treat a condition and so forth, well, we all age. And there are specific changes which occur with aging, which we can counter with different ways of neurostimulation. Again, it's well known, for example, that there is a decrease of the occipital alpha rhythm, there is a decrease of rolandic alpha, there are changes in receptors important in the cognition processes, in the density, in subunit composition and so forth, but you know, we're not on a neuroscience conference, so we can explore it later on if there is an interest in those specific technicalities, biotechnicalities. Also, what about sensory enhancement, including even for entertainment purposes in gaming? In fact, there are different ways of neurostimulation that can enhance pretty much any of your 5 senses, that can alter your perception and so forth. So it's a big deal to explore there from the entertainment viewpoint and perhaps psychology viewpoint and so forth. Again, one of the questions I've been asked and one of the answers I was always giving to this question of, again, you know, okay, aging, fine, but why else do we need to enhance a healthy human cognition capability? Is I was always countering it by saying, well, please show me a healthy human. You know, please show me someone who is not stressed, who doesn't experience mild depression, whose sleep is perfect, and so forth. In fact, when I was giving a talk on the topic of neurostimulation in the past, I was asking everyone to raise their hands up and then asking, you know, whether you actually are overworked, whether you're stressed, whether you experience any sort of emotional disbalance, whether you are neurotic, whether you are an insomniac, and so on. And then at the end, out of 130 people, I think I had 5 hands left in the air. We can do it now, but I think we've got more interesting things coming up. And that's the last point on the why slide. Correcting borderline disorders we all have at some point. So how do we do it? General methodologies. Biophysical stimulation, which is broadly could be split into electromagnetic, ranging from static field or direct current, and ultra low frequency stimulation to visible light, where the wavelength is obviously in nanometers, hundreds of nanometers. It could be mechanic, in particular acoustic, and in particular ultrasound neurostimulation is interesting. Now, what makes it different from pharmacology is you can employ biophysical methods of neurostimulation during sleep at a specific sleep stage, which is a bit difficult to do in terms of administering a drug, especially if you're experimenting on yourself, especially if it's a garage science setup. And here I've mentioned NeuroOn, a new device that came from Poland that actually monitors your sleep phases, and you can use it to adjust your sleeping patterns, and as the creators of the device claim, cut your sleep down to 2-3 hours per day without any impact on performance, or actually with performance being improved. And it was very successful at Kickstarter. There was a research from Marshall Group which used slow pulse current stimulation during sleep, and they had memory consolidation improvement with it and so forth. So you can't really do it with drugs. Okay, you have or more specifically neurofeedback methodologies, which, as we will explore, go well with biophysical stimulation, and then obviously you have old good pharmacology from Georgia times and earlier. So all of it can be successfully combined in a single methodology. Again, a very interesting thing to explore. Now, a very brief sort of semi-technical slide saying, you know, don't let the term stimulation to deceive you. Neurostimulation can have both excitatory and inhibitory, as well as more complex effects. So it's not just making neurons to fire more. And at the end of the day, in terms of cognition improvement, what we're looking for is finding out the desirable effect window, which would depend on what kind of stimulation we use. Depends on the task performed, even on a task stage. Depends on the individual characteristics, depending on group characteristics, depending on the environment, and so on. So at the end of the day, we come to the point that it's more like neurofeedback, and as I've said, it could be combined with it, rather than a single method which would work for everyone. Just push the button and your memory is improved. Well, to a point it is possible, but, and then interesting things start. How do we tailor it? So the first thing is measurement. When people talk about stimulation, they forget about the fact that we also want to see the effects, adjust the effects. Obviously, real-time measurement is highly desirable. We need a feedback loop to control and adjust stimulation. Again, to have neurofeedback, we need that loop. That, even in conditions of garage science, will generate valuable data to develop novel stimulation methods and so on. And then obviously sharing this data allows crowdsourcing and crowdfunding. that's a brilliant point. You know, why not to pay for data? Why not to gather together and get data, share data? You know, you need something to share. But the bottom line there is that the accessible stimulation methods must be compatible with the accessible measurement techniques. So let's look at the techniques very briefly. First of all, yes, we can use psychological testing at sites like quantifiedmind.com and so forth. Then EEG is getting more and more common, and here I put EEG-like because, for instance, with this TrueSense Kit sensors I'm wearing, it's more like EEG-like than EEG proper, with its own advantages and disadvantages. And then the interesting thing is what I call metabolic assessment here. I mean, you probably all heard of fMRI, you've heard of PET, and you probably also know that you know, proper fMRI setup would cost you perhaps up to £1 million or more. You have to go to a hospital, a research institution, and so on. Now, there are actually ways to do it at home. I'm doing it now with the device in my pocket here, which is a very slow potentials measurement and analysis device, what it's called an omegametry at times, even though there are more than omega. There's so-called lambda waves and so forth. There is also functional near-infrared spectroscopy, which is also getting accessible. So, for instance, by looking at this device in my pocket, now I can say that my left prefrontal cortex is clearly dominant over the right. It's minus 9.4 millivolts. If it was plus, then it would have been the right side, and then you can obviously judge on how one compared between both electrodes reading the potential, and what it effectively shows is the level of oxygenation of brain tissue under the electrode. Now, and these are the EEG sensors. I'm not sure whether they work at the moment. They did work in the past. I see them paired. Let's see if I launch them. Usually, EEG goes up to maybe gamma range, maybe up to 40 hertz. These small guys have really nice resolution, sampling rate, good amps, sampling rate 512 hertz. So here with them I can go up to 256 hertz. So this is a much broader spectrum than the normal EEG. Let's see if they work on fire. In the meanwhile, it's a bit slow. In the meanwhile, we'll go back to the presentation. So just to demonstrate, all of it is accessible. We're not really interested in results right now. Now, there are obvious problems of measurements, which are meaningful correlations between the measured data and cognitive performance. So, I mean, psychological tests are obviously to the point, but they're not real-time. Real-time data gathering, trying to correlate things like EEG readings and cognitive performance or concentration and so forth is obviously an ongoing research. There were lots of optimism about it back in the 80s, then it faded away, then it slowly comes back, and you know, there are many Nobel Prizes to be reached there. And it's not as easy as it might seem, judging by popular literature. Now, evoked potentials could be far more interesting in this sense because you can relate them to specific tasks. However, again, A, there is not enough data, and B, for lots of different gadgets coming up now for different mind-machine-brain-computer interface, things you've probably seen, things you may have used in the past. Things like MindWave, for example, maybe some of you have this kit. It has only one active electrode here. So EEG there is meaningful only for the frontal cortex, central frontal cortex. For those who are physiologists, that's FPZ. However, there's lots of interesting cognition data can be derived from measuring evoked potentials at FPZ. But there is not a single piece of software doing this analysis of data to study evoked potentials on those gadgets. So for those who want a relevant Kickstarter project, software development, open source there is a great deal of things that could be done. And then finally, it's the availability of accessible and easy-to-use quality devices. Now, near-infrared functional spectroscopy is slowly getting there. And in terms of what I've mentioned, or what I've called the metabolic measurement, measuring the metabolic activity, oxygenation level, metabolism level in a specific area of your brain. Those methods, like this box in my pocket, they, again, are not really well known to the West. This is the only box which costs about 300 pounds. I bought it in Russia from its designer, actually, and as you can see, it does the job really nicely, but at the same time, obviously, it's not that kind of a modern design you would expect on the Western market right now. For instance, if I wanted to measure the same spectrum with BrainMaster, which also supports it, I would have to pay about 3,000 pounds at least. And at the same time, it doesn't do proper filtering, it doesn't use Kropotov method, and so on. So there's big gaps there in terms of non-EEG, and the big gap with EEG is evoked potentials. So just to show some of the things which are out there and some of the things which are coming, a Motif Insight, nice EEG band should be available this summer. Muse should have been available in December. 4 electrodes, 5 active electrodes, plus reference, ground. The TrueSense kit I'm wearing right now, this is the sensor itself, this is a controller which is stuck here, and this is the memory chip which you can insert and, for example, keep the recording through your entire sleep onto this chip and then insert it into your USB port and read it and analyze it. Now, for near-infrared spectroscopy, they are still, unfortunately, not very accessible, even though brain-computer interfaces are developed at the moment. And for this little nice sensor, I've actually asked them for a price, and they said 9,000 euros. I mean, again, an electronics enthusiast can make it for pennies if there is a need. It's not a very complex methodology in terms of the actual hardware. Now, with the stimulation devices, it's even worse. And the only one device which combines stimulation and measurement is the StarStim from Neuroelectrics, which can use, it's an 8 electrodes that you can take EEG. You can also use them for stimulation as well with either direct current or pulsed current. You can't measure on the same electrode you're stimulating from. Again, when I asked them about the price, they said, oh, nice, I think it was $13,000 US. So not really an end-user box. Now, Focus makes big waves. This is a direct current stimulation device, which can also use AC or pulsed current. You can, I mean, people are buying it very actively, and it's out there. You can try it with pulsed current stimulation. This is Oasis box, which comes from the same Oasis manufacturer of mind and brain machines. A laser unit available on the market, again, overpriced for intranasal laser stimulation of the forebrain and frontal limbic system, which you can buy from Canada. And this is a totally wicked box for transcranial magnetic stimulation at high power. You can buy from Amazing One. This is the TheraPulse. So some of the things are available for an end user, but in many cases they're not perfect. They are quite often overpriced, and the main problem, they do not include, apart from the StarStim, they do not include a measurement methodology, and they may also not be compatible with existing measurement methodologies. So for instance, if you want to wear your Focus and then you want to wear your nice Motif Insight, when it comes down, it will be one less Motif Insight because it will simply burn it down. So this is where we are at the moment. Let's see how we can move forward. I will first use an example of pharmacology. So in neuropharmacology, we started from transmitter-specific drugs, for example, something that acts on dopamine receptors. Then we go to the specific receptor type, for example, something that acts at dopamine 4, D4 receptor. Then we go to subunit specificity or splice form specificity, and there you can have a specific drug acting, for example, on dopamine 4.2 splice form, which is related to risk-taking behavior and drug addiction. And then if we map the brain for this particular receptor type, then we have a hope that at a certain concentration we can target a specific brain area. So this is your typical selectivity over time evolution in pharmacology. Now, when we look at biophysical neurostimulation, not all methods are area-specific, not all methods are effect-specific, but this is usually, where we start. We select a specific area of the brain where we place, for example, our active electrode, or where we can place a coil, or where we can place a lead or a laser diode. Then we can have an on-off effect, stimulating or inhibiting. Then we move to tissue or area mechanism-specific stimulation means, where, for instance, different types of brain wave entrainment would lie. And then where we really want to get, and where I think it's possible to get, is to get to molecular or even submolecular mechanism-specific stimulation protocols. So again, this table is probably too technical for the bulk of the audience, but it summarizes different stimulation methods currently available. But what I also did is, apart from putting, whether it's really specific for a mechanism, whether the resolution in terms of stimulating, beaming it down to very narrow brain area is good. I've also added whether you can measure it in real time easily with the accessible methods, which are either EEG-like or, as I've said, in metabolic terms, functional near-infrared should be F-near. Functional near-infrared spectroscopy, and I've also added whether it's accessible for an end user, like, for example, myself. So here, again, I'm not going to dive into it deeply, but what I find most interesting is low induction pulsed magnetic field stimulation, where I think very specific mechanisms down to ligand-receptor interaction could be implemented. And also the same using modulated light in optical window of tissue permeability, 600 to 1150 nanometer wavelength. And I've seen many, many interesting things there. Now, ultrasound, as I've mentioned, you can have a very, very low resolution, up down to 2 square millimeter area specifically pinpointed and simulated. But we need to know how mechanosensitive our targets are, and only then we can talk about specific mechanisms. Now, with ultrasound, we can simply stimulate, turn on, make neurons fire. So, how do we build the thing? Now, in my opinion, from the previous table, I think that the combination of magnetic field and light stimulation is the most interesting, because it's the most specific. You can have a reasonably good resolution, and it's also safe and very non-intrusive. Attempt custom Brodmann area size targeting. It should be fully compatible with the accessible measurement means and devices. So there are plans which me and my friends have in terms of development and collaboration. Of course, it should be wireless and smartphone, table controlled, and so forth. But the most interesting thing, it should be networked. It should be bloody networked. And that's where I put this. You know, the term I've coined is the neurosocial network. So the current challenge is, you know, when we look at all those devices, those I'm wearing, those I've been showing you on slides and so on, even from the same vendor, they're not internetworked. So this really looks like, PC back in end of 70s. So the solution, which is obviously possible here, is have inter-network gadgets with appropriate control software, common data formats to exchange data between them, already there with things like EDF, EDF Plus for EEG, application layer communication stack, and shared SAS representation controls and comms GUI. Now, if we build such a network, where does it bring us? Well, you can do collective coherence stimulation, which I call the conductor mode here, similar to what the conductor in the orchestra does, inducing and promoting similarity within the group of people subject to stimulation, or you can have it decoherent for brainstorming, or what they call the diversity hive, inducing and promoting, in contrast, dissimilarity by targeting, for example, opposite side of the brain in part of the group, or by using an inhibitory protocol on one group and excitatory stimulation protocol on the other, and so forth. Other, what they call direct neurosocial engineering, collective digital nootropics or global scale enhancement, collective neuro or biofeedback, including using peripheral sensors. I've got a few with me, including collective control of virtual characters, collective control of game and film storylines, slowly comes in, collective control in robotics and so forth. And then obviously when we have this hive of sensors and stimulators, then we can also study global factor effects, including geomagnetic factor effects on our consciousness, or you can also gather lots of useful research data. So this is a huge, huge task, huge thing. So to start somewhere, I have to say that I'm testing novel neurostimulation methodologies for over 2 years with some rather interesting results, including those potentially obtained now, using EEG, using very slow potentials measurements, of course subjective observations as well. Now schemes and components are laid out, the team is there, and unless there is sudden investment, we will bring it to Kickstarter at some point in a few months. Now, the transhumanist thing. Yep. Would the envisioned neurosocial network bring us closer to the creation of the hive over self, or feedback noosphere, how we might call it, and maybe ultimately the singularity without having any detrimental effects upon us as individuals? And in the meanwhile, any smartphone, tablet, or other computer can be turned into a low induction magnetic field neurostimulation device for penis. Again, my bug is there down. I can show you how it's done. I can do it now if you want to, and measure as well. And referring back to the previous lecture on Africa, I mean, everyone has got a mobile phone now. So you plug in a coil or a few coils, you position them correctly, you give a correct signal, you have your result. Instead of coils, perhaps with more power and additional battery, it could be LEDs or laser diodes and so forth. So in practical terms, and as I've said, I'm more interested in hows than whys, you are probably well familiar with this scheme from Kurzweil showing different epochs of evolution. So we are trying to get to number 5 here in practical terms. And that's the end for today.
Andrew, thank you very much.
It's very, very slow. And in the meanwhile, I think one of the electrodes has disconnected or dried out. So one of the major problems is availability of devices with dry electrodes, and at the same time, reasonable measurement quality.
We have time for a couple of questions. Gentleman in front, and then Julie.
No, I'm just saying on what basis you say that TDCS is safe, because I think there's not enough research yet to really... I would say that there are some side effects in some people, so I wouldn't advocate everybody to do it without reading the research first.
Well, first of all, if I go back to the table, because I guess for technically minded is the most interesting part. First of all, I'm doing it all in comparison with other methods. And when I say it's safe and I put the maximum number of pluses here, I obviously assume that it's safe if it's done properly with lots of factors taken into account. I mean, it's safe. One of the, again, for neuroscientists here, for me, one of the major decisive moments in this definition is whether the method actually makes neurons fire. And whether the method actually makes neurons fire. Because with direct current stimulation, you only increase probability of firing, right? So you still need the...
We don't really know how it works. That's the reality.
Oh, we do. With direct current stimulation. We don't know exactly which path the current goes. But generally, the mechanism is quite simple here. Now, when you make neurons fire, so TDCS in this case, I compare it to ampakines. Yeah, they increase the probability of depolarization. Now, where you get the actual depolarization, there you can get seizure activity, there you can get excitotoxicity and so forth. So yes, of course, there are underwater stones there, but as compared, for example, to the normal high induction TMS, when we talk about induction of like 1 Tesla, 2 Tesla, and you know, you put the coil next to the motor cortex and you press the button and the appropriate limb jerks. You know, as compared to that, it's obviously safe.
There's a question here.
Jabida Ali from Geek Chic again. Thank you for an interesting talk, most of which I didn't understand because obviously I must misspout in a different kind of way. So I'm going to ask what everybody else in the room is thinking. I've already become the weird sex lady of the conference, so I've got nothing to lose. Can this technology give me an orgasm when my partner's in Yorkshire?
Well, one of the points on the Y slide was enhancing sensory experience. So that could be a tactile experience. That could be anything. You know, you can stimulate the acoustic cortex before going to the opera, and you can obviously enhance your tactile perception before having sex. I guess that really would help to some people. So it's like with the DCS. It doesn't really make you fire, but it increases the probability, right?
There's a question there. That's a good answer.
Matt Monarch.
Right.
John. Matt Monarch, brain.
We're invested now.
Good. But generally, yeah, or if, for example, you know, you are a wine lover or a gourmand, you know, you can enhance your gustatory sensitivity, you can enhance your taste before going to an exquisite restaurant. But on the other hand, of course, the accessible technologies I'm talking about, they can be used at the very social top, but they also, there's an ongoing argument whether cognition enhancement can actually help the third world countries to catch up. And in this sense, if it's not a drug you have to constantly take and pay, if it comes to sticking a small appliance into your phone, which costs pennies, you know, a few solenoids, a few LEDs, positioning it correctly on your head, and then running a software which could be free and open source, and then pushing the button, then it really is accessible then.
There's a next question here.
Matt Monarch, brain tech enthusiast. I think the major adoption will come not from the retail environment, but from mainstream clinical applications. For example, one of the methods, if it's not on your list, the deep transcranial magnetic stimulation done by Brainswave from Israel, is commercially available and it's sold to hospitals around the world. It has been approved by FDA for one of the conditions, several conditions in third stage clinical trials. It goes 6 centimeters into the brain tissue, etc., etc. So it's quite good. So they are making actual sales, and the clunkiness of the retail contraptions is still terrible.
Can I ask a question, because we're getting quite close to the break?
The question is, would you agree that the actual mainstream adoption will come from clinical solutions as opposed to ritual gadgets?
Well, depends on your aims. I mean, here we are talking about, or I'm talking about, enhancing the what is called the normal human, which I think is a very rare species, indeed. And clinical-wise, I mean, anytime, let's say transcranial direct current stimulation is the simplest example, right? You can do it with a 9-volt battery without, great. But as soon as you have a device which has medically approved stamp on it, then, you add 2 zeros to the price. So suddenly it stops being accessible. Yeah. Well, sure. No. So that's one of the issues. So, and then obviously we are talking about adaptation of those methods to everyday life. And if you look at focus, for instance, which is sort of the first mass stimulator out there, and that sort of shows how much time passes from discovery of the method to, I mean, it was used back in the beginning of 19th century, right? It was called galvanization at that time. So then I've got lots of data on successfully using it on, for example, ADHD children or children with development difficulties from 60s USSR, from Bekhterevo Institute. And only now we have commercial device, right? So Focus was advertised for gamers, that it increases your concentration and makes you win in shoot 'em up competitions, things like this. So this is obviously an interesting marketing trick, perhaps, but that's what it's sold for if you go to the Focus side.
Okay, so focusing on brevity. Quick question, quick final answer before we go to the break.
Okay. What are your thoughts on security regarding networking your senses and your brains, specifically exposing it to the internet?
Well, first of all, this is the question of safety in terms, if you control the device, can you really damage the brain of its user? So there, it actually comes to the device itself being foolproof in a non-networked mode. Then, of course, yes, if we have a network which collects data and can also influence the brains or areas of the brains which produce that data, that obviously gives an entire new definition to a computer malware term. So yes, there are obvious risks there. But a common end user question is, can it be used for mind control, and obviously, or thought reading and so forth. And obviously, at this stage, at this level, we're not talking about the resolution that would ever allow this. Not at this point. I mean, if you have my EEG, you can, for instance, read from those sensors now, you can tell which area of my prefrontal cortex is more active, left or right. You can tell a few other things. You can tell whether I'm concentrated or relaxed. You can tell perhaps whether I've been just solving a complex mental task and maybe even something on the character of that task. This could be useful in neuromarketing, but this is by no means thought reading or mind control.
Andrew, you read my mind there about coffee.
Coffee.
On that particular note, I'd like to thank you once again, and we'll have some stimulation after.